Good evening, passenger. The current year is 2167, ship time, and you are safely aboard the interstellar vessel Solace, preparing for departure. Outside your cabin, the crew has completed pre-flight checks and sealed all sections for departure. Inside your private room, environmental settings have been adjusted for rest. Temperature at 21 degrees Celsius, artificial gravity stabilized at 0.9 G, and observation windows dimmed for comfort. You may hear faint sounds in the distance, vibrations through the hull, the low hum of the central fusion drive warming for acceleration. There is no need to respond or leave your bed. All communications are handled automatically. If you require anything, the service crew and medical staff remain available through the call interface beside you, as they reminded you earlier during boarding. Our destination this evening is Proxima Centauri b, a rocky world orbiting a red dwarf star approximately 4.24 light-years from Earth, located in the constellation Centaurus. This voyage marks humanity's first interstellar settlement mission, a continuation of life beyond the solar cradle. We will travel at a sustained velocity of 0.2 c, 20% the speed of light. In standard terms, that is a journey of 21 years. For you, however, due to the nature of deep transit rest, this passage will feel like just under 2 hours. During that time, we will traverse familiar landmarks, the Moon, Mars, the outer planets, and the heliopause at the edge of the Sun's influence. Beyond them, you will witness the deep silence between stars, the faint glow of distant nebulae, and eventually the crimson light of Proxima Centauri itself as we approach. Please remain still in your bed, passenger. Your journey begins in 60 seconds. Outside your window now, you can see Earth. We are in high orbit, 400 kilometers above the surface. But if you look closely, you will notice changes. The coastlines are different from the maps you may remember. Sea levels have risen by 3.2 meters over the past century. Cities that once stood near the ocean are now partially or fully submerged. Infrastructure has been abandoned. Populations have retreated inland. The atmosphere carries more heat than it did 50 years ago. Global average temperature has increased by 10.6 degrees Celsius. Weather patterns have destabilized. Droughts persist in regions that were once fertile. Storms intensify in frequency and strength. The agricultural systems that sustained billions are failing. This is not a sudden catastrophe. It is the result of centuries of accumulated change. Humanity recognized this decades ago. Some succeeded locally, but the planet as a whole continues to warm. The momentum of climate change is too great to stop within any useful time frame. So a decision was made, not to abandon Earth, but to extend it, to carry its life, its knowledge, its potential to other worlds, where conditions might allow a second beginning. That is why you are here. Proxima Centauri b is a world approximately 1.3 times the mass of Earth. It orbits within the habitable zone of its star, meaning liquid water can exist on its surface. The planet is tidally locked. One side always faces the star, the other remains in darkness. But between them lies a terminator zone, a band of perpetual twilight where temperatures are moderate and stable. That zone is where we will establish the first colony. We carry soil cultures, atmospheric processes, and the knowledge necessary to transform barren rock into fertile ground. This mission will take generations. The day you plant the seeds is not the day you eat the fruit. but you will witness the first signs of growth, and those who come after will continue what you started. Proxima. Centauri B will not replace Earth, but it will preserve what Earth created. It will ensure that life, thought, and meaning continue beyond a single fragile world. Countdown is beginning now. 10, 9, 8, 7. Fuel flow is stable. 5, 4. All systems are confirmed. 2, 1. You will feel a gentle pressure now, pushing you more to left side of your bed. This is normal. We are accelerating at 1.1 g. Slightly more than Earth's gravity, but not uncomfortable. This will last for approximately 40 minutes until we reach cruising velocity. Take a look one last time. Home is fading away, but the moon is rising into view now on your left. It has orbited Earth for 4.5 billion years. It has witnessed everything: the formation of oceans, the emergence of life, the rise of civilizations, and now our departure. We are accelerating smoothly. All systems remain green. Earth is smaller now. No worries, you are not leaving Earth behind. You are carrying it with you. Every atom in your body was formed on that planet. Every breath you have ever taken was made possible by its atmosphere. Every thought you have ever had exists because Earth created the conditions for consciousness to emerge. Wherever we go, the garden comes too. Acceleration will continue for 30 more minutes. Then we will reach cruising velocity and the engines will reduce to idle. The pressure will cease. You will feel nearly weightless as the habitat module's gentle rotation provides minimal artificial gravity. You do not need to remain awake for the full duration. Many passengers prefer to drift in and out of rest as we travel. The journey will feel seamless. Time will pass differently here, slowly, gently, without urgency. Should you choose to close your eyes, do so now, and keep your mind open. The ship will guide you through every horizon. You are safe. Welcome aboard, Solace. Your journey has begun. Evening, passenger. You may have noticed the pressure has lifted. We have reached cruising velocity, and you should feel nearly weightless now. Just a gentle pull from the habitat rotation, about 1/3 of what you felt on Earth. Your arms float slightly if you let them rest. Your hair, if it is long enough, drifts around your face. This is how you will feel for most of the journey. If you need to move around your cabin, do so carefully. Your body will feel lighter, and movements will carry you farther than you expect. The bathroom and galley are equipped with handholds. Meals are in the cabinet to your right, pre-prepared, vacuum-sealed, designed to rehydrate with warm water. The ship provides 3 meals per cycle, though you may eat whenever you wish. Time here is yours to structure. To your left, through the observation port, the moon is passing close now. 50,000 kilometers away, closer than most satellites orbited Earth. Look at the surface. Those dark patches are called Maria, Latin for seas, though they contain no water. They are plains of solidified lava from volcanic eruptions that occurred over 3 billion years ago. The bright areas are highlands, older terrain covered in impact craters. Notice the sharpness of the shadows. On Earth, shadows are soft because the atmosphere scatters light. Here, there is no air to scatter anything. Light either strikes a surface directly, or it does not. The line between sunlight and shadow is absolute. This is how Proxima Centauri b will appear as well. A world of stark contrasts, where the day side is brilliant, and the night side holds complete darkness, with only the terminator zone offering the softness of twilight. The temperature difference on the Moon is just as extreme. Where sunlight falls, the surface reaches 127 degrees Celsius, hot enough to boil water. In shadow, it drops to minus 173 degrees Celsius. If you were standing there, one side of your body would freeze while the other burned. Proxima b will have similar extremes on its day and night sides, which is why the colony will be built in the terminator zone, where temperatures remain stable between minus 10 and plus 20 degrees Celsius. The Moon is behind us now. Ahead there is only darkness and the steady points of distant stars. In about 2 hours, Mars will appear in the forward viewport. Until then, you might want to rest. Many passengers sleep through this section. The journey is long, and your body will tell you when it needs rest. Listen to it. The distance from Earth is now great enough that radio waves take several minutes to reach us. If you were to send a message home, it would arrive 5 minutes late. By the time someone read your words and replied, 10 minutes would have passed. Conversation across this distance becomes something else, not dialogue, but letters sent into the growing gap between where you are and where you were. When we reach Proxima Centauri, messages will take 4.24 years to travel each direction. A question asked and answered over 8 years. Communication will become a legacy passed between generations rather than a conversation. Mars is visible now, a bright orange point ahead, growing larger as we close the distance. The color is rust, iron oxide covering the surface, the same compound that forms when metal is left in rain on Earth. But Mars has no rain. That rust is ancient, formed billions of years ago, when the planet still had liquid water and a thicker atmosphere. If you could stand on Mars, you would weigh about 1/3 of what you weigh on Earth. The gravity is weaker. Jumping would feel effortless, but breathing would be impossible. The atmosphere is less than 1% the pressure of Earth's, and it is almost entirely carbon dioxide. You would lose consciousness in 15 seconds without a pressure suit. The surface temperature averages minus 63 degrees Celsius, though at the equator during summer it can rise to 20 degrees. Cool, but not unbearable. The problem is the nights. Temperatures drop to minus 100 degrees Celsius after sunset. Without a thick atmosphere to hold heat, the planet cools rapidly. Mars once had rivers. We know because rovers and orbiters have mapped dried valleys, ancient lake beds, and delta formations where rivers once met seas. Liquid water flowed across the surface for perhaps 1 billion years. But 3.5 billion years ago, the planet lost its magnetic field. Without that protection, the solar wind, the constant stream of charged particles from the sun, stripped the atmosphere away, molecule by molecule. Water evaporated or froze into the soil. What remains is a desert, a world that almost became a home, but lost what it needed to sustain itself. This is why Proxima b was chosen carefully. It has a magnetic field, weak but present, generated by a molten iron core. That field will protect the atmosphere we introduce, allowing it to thicken over time rather than be stripped away. Mars teaches us what to avoid. Proxima b has what Mars lost. Mars passes now to the right. Watch it shrink back into a point of light. That is the last planet you will see with a solid surface until we reach Proxima b. You are entering the asteroid belt now. You will not see much. Despite the name, the belt is mostly empty. The average distance between asteroids larger than 1 kilometer is about 1 million kilometers. If you were standing on one, you would not see another nearby. The dramatic depictions in old films, ships weaving through dense fields of tumbling rocks, are fiction. Reality is emptier. The ship will make small course adjustments as we pass through. You may feel brief vibrations, tiny pulses, as maneuvering thrusters fire. They last only seconds. There is no danger. The navigation system is tracking every object in our path and steering us around them. These rocks exist because Jupiter prevented them from becoming a planet. When the solar system was forming, this region should have gathered into a world. But Jupiter's gravity was too strong. It stirred the material violently, causing collisions that shattered rather than built. What you are passing through now is debris, the fragments of a planet that never was. Sometimes potential is interrupted. What remains still orbits, still follows the same path it has for billions of years, waiting for nothing in particular. We carry samples of these asteroids in the cargo hold. They contain metals, iron, nickel, platinum, and water ice frozen into their structure. When the colony on Proxima b is established, these materials will be invaluable. Asteroids will be mined to build infrastructure, to extract water, to provide raw materials that the planet itself may not offer in abundance. What was once debris becomes resource. What was interrupted finds new purpose. Jupiter is ahead now, a bright disk with faint bands of color growing steadily larger. In about 10 hours, you will pass close enough to see details. Until then, you might want to sleep. The galley can prepare a warm drink if you wish, tea, coffee, or broth. The interface beside your bed allows you to select. The view will not change much for several hours. Just darkness, and that single bright point growing slowly larger. Jupiter is filling the viewport now. It is the largest planet in the solar system. If it were hollow, you could fit over 1,000 Earths inside it. But Jupiter is not hollow. It is a ball of hydrogen and helium compressed by its own gravity, with no solid surface to stand on. If you fell into Jupiter, you would descend through clouds, then denser gas, then liquid hydrogen, until the pressure crushed you long before you reached the core. At the center, pressures exceed 2 million times Earth's atmospheric pressure. Matter behaves strangely there. Hydrogen becomes metallic, conducting electricity like liquid metal. The great red spot is visible, that oval near the center. It is a storm larger than Earth, with winds exceeding 400 kilometers per hour. It has been raging for at least 350 years, possibly much longer. If you lived on Earth near the equator, you might have experienced a typhoon or hurricane. Winds of 150, maybe 200 kilometers per hour. Enough to tear roofs off buildings and uproot trees. Now imagine winds twice that fast, sustained not for days, but for centuries. That is what you are looking at. The color comes from chemicals brought up from deep inside the planet. Sulfur and phosphorus compounds that change when exposed to sunlight. The storm is red for the same reason rust is red. Chemistry and light. Proxima Centauri is also an active star. It produces powerful flares, sudden bursts of radiation that can increase its brightness several times for minutes or hours. These flares are driven by magnetic activity on the star's surface, similar to what powers Jupiter's storms, though far more intense. The colony habitat will be shielded against these flares. Structures will be built partially underground or within natural rock formations to provide protection. The architecture of survival is being designed now, informed by what we observe here. Look at the moons. 4 bright points near the planet. Those are the Galilean moons: Io, Europa, Ganymede, and Callisto. Galileo saw them in 1610 with a simple telescope. Their existence proved that not everything orbits Earth. That single observation shifted humanity's understanding of its place in the cosmos. Io, the closest moon, is covered in volcanoes. It is the most volcanically active body in the solar system. The surface is constantly reshaped by eruptions of sulfur, reaching temperatures over 1,600 degrees Celsius. This happens because Jupiter's gravity squeezes and stretches Io as it orbits, generating heat through friction. This process is called tidal heating. Europa, the second moon, is covered in ice. But beneath that ice is an ocean, liquid water, possibly 100 kilometers deep. More water than all of Earth's oceans combined. The ice shell is 10 to 15 kilometers thick, cracked and shifting, indicating the ocean below is active. The same tidal heating that powers Io's volcanoes keeps Europa's ocean liquid, despite being so far from the sun. If life exists anywhere else in the solar system, Europa is a strong candidate. The ocean is in contact with a rocky seafloor. On Earth, hydrothermal vents on the ocean floor support ecosystems that do not need sunlight. Bacteria live off chemicals released by the vents. Larger organisms feed on the bacteria. An entire food chain, independent of the sun. The same could exist on Europa. We do not know yet. No mission has drilled through the ice to confirm. But this is why we search. This is why we travel. Life may be more common than we imagined, existing not only on sunlit surfaces, but in dark oceans beneath ice, in underground caves, in places we have not yet thought to look. Proxima b may already harbor microbial life in its subsurface regions, adapted to the dim red light and occasional flares. Or it may be a sterile, waiting for us to introduce the first cells. Either way, the search continues. Ganymede is larger than the planet Mercury. It has its own magnetic field, the only moon known to have one. Callisto is the outermost, heavily cratered, ancient and still. Jupiter is behind you now. Its light fades as distance grows between you and the largest world you will ever see in this solar system. Saturn lies ahead, a pale yellow point that will take another 16 hours to reach. You should rest. The ship will dim the cabin lights gradually if you request it through the interface. There is nothing to see until then except darkness and your own thoughts. Some passengers prefer this time for reflection, others sleep. Both are valid. Saturn is close now, and the rings are visible. Even from this distance, they are unmistakable. A bright, flat disk surrounding the planet, gleaming in the sunlight. The rings are made of ice. Billions of chunks, ranging from grains of sand to boulders several meters across, each one orbiting Saturn independently. The ring system stretches 280,000 kilometers from edge to edge, more than twice the distance from Earth to the Moon. Yet most of the rings are only 10 meters thick. Imagine something the width of a continent but the height of a 3-story building. That is how thin they are. If you could fly through the rings, you would see each piece tumbling slowly, colliding gently with others, breaking apart and reforming. The entire system is in constant slow motion. It looks solid from a distance, but up close it is all individual fragments held together by nothing but gravity and momentum. The rings will not last forever. Gravity is pulling the material inward, slowly but inevitably. In 100 million years, they may be gone entirely. You are witnessing something temporary. Beauty often is. Look at Titan, the large moon to the right. It is the only moon in the solar system with a thick atmosphere. Thicker than Earth's, in fact. If you stood on Titan, the air pressure would feel similar to standing on Earth at sea level. But the air is not breathable. It is 98% nitrogen, with methane and ethane mixed in. The surface temperature is minus 179 degrees Celsius. Lakes and rivers exist there, but they are not water. They are liquid methane and ethane, flowing across the surface like water flows on Earth. It is the only other place in the solar system with stable surface liquids. Rain falls there, methane rain, cold and slow, evaporating from lakes, condensing in the atmosphere, and falling again in a cycle that mirrors Earth's water cycle, but with entirely different chemistry. This teaches us something important. Familiar processes can occur under alien conditions. Cycles of evaporation and precipitation, erosion and deposition, weather and climate. These are not unique to Earth. They are patterns that emerge wherever energy and matter interact. Proxima b will have its own cycles, driven by the temperature difference between its day and night sides. Winds will blow from hot to cold, carrying moisture, redistributing heat. The terminator zone will experience weather, perhaps gentle, perhaps violent, but weather nonetheless. You will live within that system, learning its rhythms, adapting to its patterns. Saturn is behind us now. The outer planets, Uranus and Neptune, lie farther out, but our trajectory does not pass near them. We are angling upward, out of the plane where most planets orbit, leaving behind the architecture of the system that built you. As we move farther outward, the sun behind us has become a brilliant star, no larger than your thumbnail held at arm's length. Its warmth no longer reaches the hull directly. The temperature outside has fallen far below anything the human body could imagine, approaching minus 250 degrees Celsius. Yet inside, the air remains gentle, the same softness you knew before launch. The ship maintains this environment constantly. The heating system draws energy from the fusion reactor, the same reactor that will power the colony on Proxima b for decades before solar infrastructure can be established. This vessel is a prototype, a proof that humans can create stable environments even in the harshest conditions. Ahead is the heliopause, the edge of the sun's influence. The sun emits a constant wind of charged particles, protons and electrons, traveling outward at hundreds of kilometers per second. This wind creates a bubble around the sun, extending about 18 billion kilometers in most directions. At the edge of that bubble, the solar wind meets the interstellar medium, the thin gas that fills the space between stars. The two push against each other, and where they meet, a boundary forms. Not a wall, but a transition. A place where one kind of space becomes another. You are crossing that boundary now. You will not feel anything. The change is invisible, but instruments detect it. Particle density shifts, radiation levels change, cosmic rays from distant stars and galaxies become more prevalent. The temperature drops toward the background temperature of the universe itself. 2.7 Kelvin, leftover radiation from the Big Bang 13.8 billion years ago. You have left the solar system. Ahead is interstellar space, the region between stars. It is not empty. There is gas, mostly hydrogen, about 1 atom per cubic centimeter. But compared to anything you have experienced, it is as close to nothing as matter can be. For comparison, the air you are breathing contains about 25 billion times more molecules per cubic centimeter than the space outside. The stars ahead do not look different yet. They do not grow brighter or change position. That will take months, years. For now, everything looks the same as it did an hour ago. But you are beyond the sun's reach now. You are in the space between. The next 20 years will be spent crossing this emptiness, moving through a medium so sparse it barely exists, toward a faint red star that will slowly, incrementally, begin to outshine all others. Rest if you wish. The next landmark is far ahead, and there is time. The galley remains available. The interface can provide music, white noise, or silence, whichever helps you sleep. Your journey has only just begun. The journey continues. Passenger. We are now several days into the journey. Ship time. You may have lost track of how long you have been awake or asleep. This is normal. Without the sun rising and setting, your circadian rhythm will drift. The ship can simulate a day-night cycle in your cabin if you wish. The lights will brighten gradually over 30 minutes to mimic dawn, then dim slowly 12 hours later to mimic dusk. Many passengers find this helpful. The interface beside your bed allows you to enable it, or you may choose to let your body find its own rhythm. There is no wrong way to experience this time. Outside, nothing has changed visibly. The stars remain fixed in their positions, though they are shifting by fractions of degrees each week as we move. The sun behind us is now just another bright point in the constellation Sagittarius, indistinguishable from other stars unless you know exactly where to look. We are in the interstellar medium now. This is the space between stars, and it is as close to emptiness as the universe permits. The density here averages 1 atom per cubic centimeter. Most often that atom is hydrogen, the simplest element, a single proton orbited by a single electron. Occasionally there are traces of helium, carbon, or oxygen. Sometimes dust grains, so small they would fit on the head of a pin, coated in ice, water, methane, or ammonia frozen at temperatures near minus 270 degrees Celsius, just 3 degrees above absolute zero. For comparison, the air in your cabin contains about 25 quintillion molecules per cubic centimeter. That is 25 followed by 18 zeros. Out here, there is one atom. The difference is so vast that words struggle to convey it. This is as close to nothing as matter can be, without vanishing entirely. The ship is moving through this medium at 60,000 kilometers per second, 20% the speed of light. At this velocity, even the sparse hydrogen atoms we encounter produce measurable effects. They strike the forward magnetic shield and are deflected around the hull, creating a faint bow shock similar to the way a boat creates a wake in water. You will not feel this. The forces involved are minuscule, but the ship's sensors detect them, tracking the particle flux, adjusting the magnetic field strength to compensate. This same technology will be used on Proxima B. The magnetic field generators in the cargo hold will be deployed on the surface, creating artificial magnetospheres around the colony sites to deflect solar wind and radiation from the star's flares. What protects us now will protect you then. The systems are tested here, refined here, proven reliable across millions of kilometers. My volume now shall be decreased for you to sleep. But if you wish to listen, I'm still here, just a bit smaller. I want to draw your attention to something ahead. It is very faint, very distant, but significant. We are approaching the trajectory of Voyager 1. Voyager 1 is a spacecraft launched from Earth in 1977, nearly 2 centuries ago. Its mission was to study Jupiter and Saturn, which it did successfully, sending back the first detailed images of those worlds and their moons. But it did not stop there. It continued outward, propelled by the gravity of the planets it visited. And in 2012, it became the first human-made object to enter interstellar space. Voyager is still out here. It travels at about 17 kilometers per second, much slower than we are moving, but remarkable for a machine built with 1970s technology. Its power supply is fading now. The plutonium-238 that generates electricity through radioactive decay is nearly exhausted. The spacecraft went silent decades ago, sometime in the 2030s, but it continues moving, coasting on momentum, and will do so for millions of years. We will not see it. It is too small, too far off our direct path. But we are passing through the same region it crossed over a century ago, following in the wake of humanity's first messenger to the stars. Attached to Voyager is a golden record, a 12-inch disc, plated with gold to resist corrosion, containing sounds and images from Earth. There are greetings in 55 languages, music from different cultures and eras, Bach, Beethoven, Chuck Berry, traditional songs from across the world, natural sounds, thunder, wind, birdsong, whale calls, human laughter, diagrams showing Earth's location relative to pulsars, so that anyone finding the record might trace its origin. One of the greetings was recorded by a child speaking in English. The child said, "Hello from the children of planet Earth." The golden record was not sent with any real expectation of being found. The chances are infinitesimally small. It was sent as a gesture, a statement that we existed, that we reached out, that we wanted to be known. Not for practical reasons. but for the same reason you might write your name on a tree or carve it into stone. To say, I was here, we were here, we mattered. Before you left Earth, you were given the opportunity to record one final message, a transmission sent back as the ship crossed the heliopause, Earth's last words to those who remained. Many passengers chose to send personal messages to loved ones. Others sent nothing, preferring to carry their memories forward in silence. But there was one message transmitted on behalf of the entire mission, encoded and broadcast on all frequencies. A single phrase: the treasure is in the dark side of the moon. The dark side of the moon is a misnomer. There is no permanently dark side. The moon rotates once every 27.3 days, the same time it takes to orbit Earth. This synchronous rotation means one hemisphere always faces Earth, the near side, while the other always faces away, the far side. But both sides receive sunlight. Both experience day and night. The far side is not dark. It is simply unseen from Earth. For centuries, humans could only observe the near side. The far side remained a mystery until 1959, when a Soviet spacecraft orbited the moon and sent back the first images. What they found was different from the near side, more heavily cratered, with fewer of the dark lava plains called Maria. The far side had been shielded from view not by darkness, but by position, by perspective. The message, the treasure is in the dark side of the moon, is a reminder that what is hidden is not lost, what is unseen is not absent, and often the most valuable things lie precisely where we cannot yet look, in the places that require us to move, to change our position, to see from a different angle. You are moving now. You have left behind the near side, the familiar, the visible, the mapped. You are traveling toward the far side of existence, the regions humanity has not yet seen directly. And the treasure is not in looking back, it is in continuing forward into the unseen. This is true in your own life as well. Every person carries a far side, aspects of themselves not readily visible to others, perhaps not even to themselves. Potential that remains dormant until circumstances change, until perspective shifts, until you move into a position where what was hidden becomes clear. The interstellar medium around us is mostly hydrogen, the simplest element. Yet hydrogen is the raw material from which everything else is built. Inside stars, hydrogen fuses into helium. Helium fuses into carbon and oxygen. Heavier stars produce nitrogen, silicon, iron. The heaviest elements, gold, platinum, uranium, are forged in supernova explosions. Every complex thing begins as something simple, transformed by pressure and time and the right conditions. You are in transit. You are under pressure, not physical pressure, but the pressure of distance, of isolation, of carrying forward a mission whose outcome will not be known for generations. This pressure is not meant to break you. It is meant to reveal what you are capable of becoming. The dark side of the moon is not dark. It is simply waiting to be seen. And you are moving toward the place where you will see it. You are doing something similar now, carrying forward not just a recording, but living biology, active knowledge, the continuation of consciousness itself. If Voyager is a message in a bottle, you are the message and the sender and the recipient all at once. You carry Earth with you, and you will plant it elsewhere, giving it form and breath and thought under a different sun. The ship is quiet now, the engines idle, maintaining velocity. There is no sound except the faint hum of ventilation, the soft clicking of life support systems, cycling air and water. Some passengers find the silence unsettling. If you are one of them, the interface can provide ambient noise. Ocean waves, rainfall, forest sounds recorded on Earth. Others find the silence comforting, a chance to hear their own thoughts without interruption. Both responses are normal. Outside, the interstellar medium continues around us, invisible but present. We are moving through the remnants of ancient stars, the raw ingredients of future worlds. The atoms brushing against our magnetic shield may one day become mountains or oceans, or living beings who look up at their own sky and wonder what lies beyond. This region is not empty. It is patient. It is full of potential waiting to be gathered by gravity into new configurations, new possibilities. You could sleep for weeks and wake to find the view almost unchanged. Or you could stay awake and watch the stars shift by fractions of a degree over months. Both experiences are equally valid. The ship does not require you to be awake. Your presence is enough. I will continue monitoring. That is my function. I will track our trajectory, maintain life support, observe the phenomena we pass. I will note variations in radiation, fluctuations in particle density, the faint gravitational influences of distant masses. I will keep the ship safe while you rest or wake, or simply exist in the time between. You are not alone here. You are accompanied by everything humanity has learned about crossing distances, about surviving in environments that were not made for us, about creating small pockets of warmth and air, and life in places that offer none of these things. That knowledge is encoded in every system aboard this ship. It is your inheritance, built by centuries of people who looked at the stars and refused to accept that they were unreachable. The mathematical models that predict our trajectory were developed over generations, refined by observations of comets and planets and spacecraft. The fusion reactor that powers this ship is the culmination of decades of research into controlled nuclear reactions. The magnetic shielding is based on principles discovered by studying Earth's magnetosphere and Jupiter's radiation belts. The life support system borrows from lessons learned on space stations, underwater habitats, and polar research bases, anywhere humans have lived in isolation from Earth's natural systems. All of that knowledge travels with you. You are not just a passenger. You are the current manifestation of a long lineage of curiosity and effort, stretching back to the first person who looked up and wondered what those lights in the sky were. Proxima Centauri is still too far away to appear different from other stars. It will not begin to brighten noticeably for several more months, ship time. But it is ahead, fixed, constant. We are moving toward it incrementally, inevitably, covering tens of thousands of kilometers every second. In the cargo hold, the biological samples remain in cryogenic storage, preserved at temperatures near absolute zero. Seeds from thousands of plant species, bacterial cultures, fungal spores, genetic material from animals that could not be transported alive, but might be reconstituted later through cloning techniques. Soil samples containing the microorganisms that make agriculture possible, the nitrogen-fixing bacteria, the mycorrhizal fungi that form symbiotic relationships with plant roots, the decomposers that break down organic matter and return nutrients to the soil. These samples represent Earth's biosphere in miniature. They are the foundation of what will be built on Proxima b. Not a replica of Earth, but an adaptation, Life shaped by 4 billion years of evolution on one planet, learning to grow on another. The process will be slow. First, the soil must be prepared. Crushed rock mixed with organic matter and inoculated with bacteria. Then hardy plants adapted to low light and temperature extremes. Lichens and mosses to begin stabilizing the surface. Gradually, as the soil improves and atmospheric processing increases oxygen levels, more complex plants. Eventually, ecosystems. You will witness the beginning of this process. The first green shoots emerging from Proxima B's rust-colored soil, growing under the dim red light of a star that has never seen life before. That moment, whenever it comes, will mark something profound. Not just the success of a mission, but the expansion of life itself beyond its planetary origin. Rest now if you wish. The interstellar medium flows around us like an invisible river, sparse and cold and patient. We are a small vessel on a very large current, but we are moving, we are continuous. The galley can prepare another meal if you are hungry. The medical panel has supplements to prevent bone loss and muscle atrophy from prolonged weightlessness. Calcium, vitamin D, resistance exercise protocols you can perform in the cabin. Your body needs maintenance, even here, even in transit. Take care of it. It will carry you to the surface of a new world. Do not look back. Not out of denial, but out of focus. Looking back is natural. The human mind seeks familiarity, safety, the comfort of what is known. But you are not traveling backward. Every atom in your body is moving forward at 60,000 kilometers per second. Your trajectory is fixed. The only direction available to you now is ahead. By the time we arrive at Proxima Centauri, 21 years will have passed aboard this ship. On Earth, approximately 21.4 years will have elapsed. Anyone you knew who was young will be middle-aged. Anyone middle-aged will be old. Children will be adults. Adults will be elderly or gone. If you look back, you will be looking at a place that no longer exists in the form you remember. The Earth you left is already in the past, not just spatially, but temporally. It has moved forward without you, and you have moved forward without it. This is why the message was sent. The treasure is in the dark side of the moon. The treasure is not behind you. It is ahead, in the unseen, in the place you have not yet reached. Your purpose is not to preserve what was, but to create what will be. Hydrogen becomes helium, becomes carbon, becomes life. Simple becomes complex. The unseen becomes visible, but only through motion. Only through the willingness to undergo transformation under pressure. You are hydrogen in the core of a star, waiting to become something more. The journey continues. There is time. There is always time. The stars ahead remain steady, though they shift imperceptibly with each passing day. Proxima Centauri is among them, still indistinguishable, still waiting. The sun behind grows dimmer, blending into the field of distant stars, becoming memory rather than presence. We are between now, no longer of the solar system, not yet arrived at our destination. Suspended in passage. This is where you are. This is where you will be for months to come. But being between is not being lost. It is being in motion. And motion has always been humanity's answer to limitation. When the first fish crawled onto land, it left behind the ocean that had sustained life for billions of years. It moved into an environment that was hostile, dry, oxygen-rich, in a way that burned. But it moved forward. And from that motion came amphibians, reptiles, mammals. eventually humans, standing upright and looking at the sky. When the first humans left Africa, they left behind the cradle of the species, moving into climates and terrains they were not adapted for. They crossed deserts, mountains, oceans. Many died, but enough persisted. And from that motion came global civilization. When the first spacecraft left Earth, it moved into an environment utterly incompatible with life. No air, no pressure, no warmth. But it moved. And from that motion came the understanding that allowed you to sit here now, breathing comfortably, traveling between stars. You are part of that lineage. You are the next step. The fish that left the ocean, the human who left the continent, the species that left the star. And the treasure is not in looking back at the water. It is in learning to breathe air. It is in discovering what you become when you move into the unseen. You are safe. The ship holds you. Keep going. The treasure is ahead. Passenger, you may have noticed a change in the ship's behavior over the past hour. Brief vibrations, subtle shifts in orientation. The cabin lighting has increased slightly to alert status, not emergency, but elevated awareness. This is normal. We are approaching a region of higher particle density, and the ship is responding accordingly. If you check the interface beside your bed, you will see a notification marked Navigation Adjustment Meteor Stream. You do not need to take any action. The ship handles this autonomously. But I want you to understand what is happening, so the sensations you feel have context rather than causing concern. We are entering a meteor stream, a region of interstellar space where dust and small rocky fragments are more concentrated than the baseline medium. The density here is still extraordinarily low by any terrestrial standard. Perhaps 1,000 atoms per cubic centimeter compared to the usual 1 atom per cubic centimeter. That sounds like a significant increase, and it is, relatively speaking. But it is still a near-perfect vacuum. The air in your cabin is trillions of times denser. The difference is that we are moving through this material at 60,000 kilometers per second. At such velocity, even a grain of sand carries tremendous kinetic energy. A single particle the size of a rice grain, striking the hull directly, would release energy equivalent to several kilograms of TNT. This is why the magnetic shielding exists. The magnetic field around the ship ionizes incoming particles, strips electrons from their atoms, and deflects them around the hull before they can make contact. What you are feeling as vibrations are micro-adjustments to the field strength and configuration, responding to variations in particle flux. The ship's systems are working exactly as designed. If you look out the forward viewport now, you should begin to see something remarkable. Small flashes of light, brief, white, appearing and disappearing in an instant. These are dust grains colliding with the magnetic field at relativistic speed. The impact ionizes the particles, releasing energy as visible light. Each flash represents a fragment no larger than a speck of sand, traveling so fast that its destruction creates a tiny burst of illumination. It is beautiful in a way, like watching rain against a window, except the rain is interstellar dust and the window is an invisible field of magnetism. The phenomenon is similar to what you would see in Earth's atmosphere during a meteor shower. When Earth passes through the debris trail of a comet, fragments enter the atmosphere at speeds of 20 to 70 kilometers per second. Friction with air molecules heats them until they glow, creating the streaks of light we call shooting stars. Most burn up completely before reaching the ground. What you are seeing now is the same process, but without an atmosphere, just raw collision between matter and energy. The stream continues. The flashes increase in frequency. The ship adjusts course slightly, threading through the densest regions, seeking the path of least resistance. You may feel the vibrations become more pronounced. This is expected. The navigation system is recalculating trajectory hundreds of times per second, making tiny corrections measured in fractions of a degree. I am monitoring particle composition through spectroscopic analysis. Most fragments are silicates, compounds of silicon and oxygen, similar to sand or glass. Some contain iron, carbon, or traces of organic molecules. Organic in the chemical sense, meaning carbon-based, not biological. These are simple molecules like formaldehyde, methanol, or amino acids, the building blocks from which more complex chemistry can emerge. These molecules form in interstellar space, despite the cold and vacuum. Carbon bonds readily with hydrogen, oxygen, and nitrogen, creating structures even in the absence of liquid water or atmospheric pressure. The universe is a better chemist than we once imagined. It manufactures complexity wherever the raw materials exist, however slowly. This dust is ancient. It predates the sun. It predates Earth. The meteor stream we are passing through likely originated from a supernova, the explosive death of a massive star. When such a star exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses in less than a second, compressing matter to densities where protons and electrons merge into neutrons. The collapse stops abruptly when the neutron core can compress no further, and the rebound creates a shock wave that tears the star apart. The explosion releases more energy in seconds than the sun will emit over its entire 10 billion year lifetime. Approximately 10 to the 44 joules. That is a 1 followed by 44 zeros. Most of that energy is carried away by neutrinos, nearly massless particles that interact so weakly with matter they pass through planets and stars as if they were not there. Only 1% of the supernova's energy goes into light, heat, and the kinetic energy of the expelled material. But even 1% of that much energy is staggering. The shockwave accelerates the star's outer layers to thousands of kilometers per second, flinging them into space. The material spreads outward for thousands of years, creating an expanding shell of gas and dust that eventually slows, cools, and mixes with the existing interstellar medium. What you are passing through now is the remnant of such an event. These particles were once part of a star's atmosphere, or perhaps its core. They were expelled billions of years ago, possibly long before Earth existed, and have been drifting through space ever since. We are passing through the ashes of creation. Not metaphorical ashes, but literal debris from a star that died so that heavier elements could exist. Every atom of oxygen you breathe was created inside a star and released by an explosion like the one that produced this dust. Every atom of carbon in your cells, every atom of calcium in your bones, every atom of iron in your blood, all forged in stellar cores or supernova blasts. You are made of this material, not similar material, the same material. Star ash, gathered by gravity into a planet, shaped by biology into a conscious being. The flashes outside are kin to you, in a sense. You are both remnants of the same process, separated by time and circumstance, but sharing an origin. This is worth understanding, not as poetry, but as fact. You are not separate from the universe. You are a continuation of it. The same forces that destroyed that ancient star also created the conditions for your existence. Destruction and creation are not opposites. They are phases of the same cycle. The dust we cross tonight will one day become another world, not soon, not in any human time frame, but eventually gravity will gather it. A new star will ignite nearby, its light and pressure compressing the surrounding material into a disk. Planets will condense from that disk, and perhaps millions of years later, someone on one of those planets will look up at their sky and wonder where they came from. They will be made of this dust, the very particles striking our magnetic field now. That continuity is not abstract, it is mechanical. Matter cycles through stars and planets and life, and back again, endlessly, each cycle adding complexity and structure. Nothing is lost. Everything transforms. On Proxima B, you will witness the beginning of a new cycle. The biological samples in the cargo hold, seeds, microbes, genetic material, will be introduced to soil made from crushed rock and organic matter. The microbes will begin breaking down minerals, releasing nutrients. The seeds will germinate, drawing energy from Proxima Centauri's dim red light, growing slowly but steadily. In a sense, you are doing what this meteor stream is doing. You are carrying the debris of one star system to another, where it will be gathered, concentrated, and transformed into something new. The process is the same, only the scale and intention differ. The meteor stream is beginning to thin now. The flashes are becoming less frequent. The vibrations are subsiding. The ship's magnetic field returns to its normal configuration, idling, conserving energy. We are passing out of the dense region, back into the baseline sparseness of interstellar space. The transition is gradual. There is no clear boundary, only a slow reduction in particle encounters until the quiet returns. I want you to understand something about turbulence. It is not a sign of danger. It is a sign of passage. We move through varying conditions, dense and sparse, energetic and calm. The ship adapts to each. So can you. Life is turbulence, not chaos, but variation. On Earth, you experienced this constantly. Weather changed, seasons shifted, circumstances evolved. You adapted. Sometimes consciously, more often unconsciously, your body and mind adjusting to new conditions without deliberate thought. This journey is no different. There will be sections of calm and sections of turbulence. Neither is permanent. Both are necessary. Calm allows rest. Turbulence requires attention. Together, they create the rhythm of travel. On Proxima B, you will experience new forms of turbulence. The star will flare, releasing bursts of radiation that require you to seek shelter. The terminator zone will have weather, winds driven by the temperature difference between day and night, carrying moisture, redistributing heat. Dust storms may rise from the day side, sweeping across the twilight region before dissipating into the cold of the night side. You will adapt. Humans have always adapted. That is what we do. We are not the strongest species, or the fastest, or the most resilient in any single category. But we are adaptive, we learn, we build. We create environments where none existed, and we survive in them. The ship's systems are designed with this in mind. The habitat modules that will be deployed on Proxima b are not rigid structures. They expand and contract based on need. They can be buried partially underground for radiation protection, or elevated on supports if flooding occurs. They are modular, allowing reconfiguration as the colony grows and conditions change. This flexibility is intentional. We do not know exactly what Proxima b will require of us. We have models, predictions, best estimates based on remote observations. But reality will differ from models in ways we cannot foresee. Adaptation requires the ability to respond to the unexpected. You carry that ability. It is not something you need to learn. It is already part of you, encoded in your biology and your psychology. Every challenge you have faced in your life has reinforced it. Every time you adjusted to change, you practiced the skill that will sustain you on a new world. The meteor stream is behind us now. The stars ahead show no change yet in brightness or position. Proxima Centauri remains indistinguishable from the thousands of other points of light scattered across the viewport. But we are closer than we were. Every moment is a closing of distance. Every second covers tens of thousands of kilometers. Rest now. The turbulence has passed. Passenger. A new star is visible ahead now. Not Proxima Centauri. We are still months away from that. This is Barnard's star, approximately 6 light-years from Earth. We are passing close enough to observe it directly. I am adjusting our trajectory by 0.3 degrees to bring it into clearer view. The course correction is minor and will not delay our arrival at Proxima Centauri. The change will take about 20 minutes. You may feel a slight shift as the maneuvering thrusters fire. This is normal. Look at the forward viewport. The star appears as a faint reddish point, brighter than the surrounding stars, but still dim. This is what a red dwarf looks like from a distance of about 2 light-years. Our closest approach. Barnard's star is old, very old, between 7 and 12 billion years old, compared to the Sun's 4.6 billion years. It existed before the Sun formed. It watched our solar system condense from a cloud of gas and dust. It will still be burning trillions of years from now, long after the Sun has died. Red dwarfs live longer than any other type of star because they burn fuel slowly. The Sun will exhaust its hydrogen in about 5 billion years, swell into a red giant, and eventually collapse into a white dwarf. Barnard's star will burn for another 10 trillion years at least, perhaps longer. No red dwarf has ever died of old age. The universe is not old enough yet. The star's surface temperature is about 3,000 Kelvin compared to the Sun's 5,800. That lower temperature means it emits most of its light in the infrared spectrum. What you see with your eyes is only a fraction of its total output. If you had infrared vision, it would appear much brighter. One planet orbits this star, Barnard's Star B, discovered in the early 21st century. It is a super-Earth, about 3 times the mass of our home world, orbiting far from the star in a cold region beyond the habitable zone. Surface temperatures there likely drop below minus 150 degrees Celsius. Too cold for liquid water, too cold for the kind of life we know. The ship's sensors are scanning the system now. No signs of artificial structures, no radio signals, no heat signatures that suggest technology or large-scale biological activity. The system is silent. This is common. Most stars are silent. Most planets are barren. Life, as far as we can detect, is rare. Perhaps not unique, but rare enough that we have not found it elsewhere, despite decades of searching. Barnard's star moves faster across Earth's sky than any other visible star. Not because it is moving faster through space than other stars, but because it is so close to us. Its velocity through the galaxy is about 140 kilometers per second. Over the next 10,000 years, it will shift several degrees across the constellation Ophiuchus, eventually appearing in a completely different part of the sky as seen from Earth. All stars move. They orbit the galactic center in vast, slow circles that take hundreds of millions of years to complete. The Sun orbits at about 220 kilometers per second, carrying Earth and all the planets with it. We are all in motion, always, even when we feel still. From here, you can see that motion beginning to become perceptible. Stars that were fixed in your view weeks ago have shifted slightly. Not much, fractions of a degree, but enough to notice if you pay attention. This is what it looks like when you move fast enough that the universe's motion becomes visible in human time frames. Barnard's star is passing now to our right. It will fade back into the background stars over the next few hours, becoming just another point of light, indistinguishable from thousands of others. I want to tell you something about longevity. Barnard's star has been burning for billions of years. It will continue burning for trillions more. It does not flare dramatically like younger, larger stars. It does not produce spectacular nebulae or violent explosions. It simply burns steadily, quietly, outlasting everything around it. This is not a lesser form of existence. It is a different strategy. Brightness is temporary. Endurance is rare. You are not the brightest person who has ever lived. You are not the most talented, or the most intelligent, or the strongest. But you are here. You endured long enough to be selected for this mission. You survived the training, the isolation, the knowledge that you would never return to Earth. You are still moving forward. That endurance matters more than any single moment of brilliance. Proxima B will not be transformed overnight. The colony will grow slowly, over generations. Success will not come from dramatic gestures, but from steady, patient work repeated across decades. Planting, watering, waiting, observing, adjusting, repeating. The people who succeed on Proxima B will not be those who burn brightest. They will be those who burn longest. Barnard's star teaches that. Small, dim, unremarkable by the standards of larger stars. But it endures. And in enduring, it outlasts galaxies. The star is behind us now. The view ahead returns to the uniform scatter of distant stars. Proxima Centauri is among them, still too far to appear distinct. but closer than it was yesterday. We are moving toward it. That is enough. Keep going. Passenger. Something unusual is happening ahead. The ship's sensors are detecting an increase in electromagnetic radiation across multiple wavelengths: visible light, ultraviolet, X-rays. The source is distant, approximately 200 light-years away, but the intensity is rising steadily. This is not a danger. We are far enough that the radiation levels remain well within safe limits. But it is worth observing. What you are seeing is a supernova echo, light from a stellar explosion that occurred thousands of years ago, only now reaching this region of space. The star died long before humans existed. The light has been traveling ever since, and we happen to be in its path. Watch the forward viewport. You should see a gradual brightening over the next 30 minutes. Not sudden, but steady, like dawn arriving in a place where no dawn should be. There. The glow is becoming visible now. Pale blue with hints of violet. This is the color of extremely hot gas, heated to millions of degrees Celsius by the shock wave of the explosion. I will explain what happened. A supernova occurs when a massive star, at least 8 times the Sun's mass, exhausts its nuclear fuel. For millions of years, the star burns hydrogen into helium, helium into carbon and oxygen, carbon into heavier elements. Each fusion reaction releases energy that supports the star against gravity. But this cannot continue forever. Eventually, the core begins fusing silicon into iron. Iron is stable. Fusing iron does not release energy, it consumes energy. When the core becomes mostly iron, fusion stops. The energy output drops, and suddenly nothing holds the star up against its own weight. The core collapses in less than 1 second. Matter falls inward at nearly a quarter, the speed of light, compressing to densities where protons and electrons merge into neutrons. The core becomes so dense that a teaspoon of it would weigh as much as a mountain. The collapse stops when the neutron core cannot compress further. The infalling material rebounds off this incompressible surface, creating a shock wave that tears through the star's outer layers. The shock wave accelerates the material to thousands of kilometers per second, ripping the star apart. The explosion releases approximately 10 to the 44 joules of energy, more energy than the Sun will emit over its entire 10 billion year lifetime, released in seconds. 99% of that energy is carried away by neutrinos, particles so weakly interacting they pass through matter as if it were empty space. Only 1% goes into light, heat, and kinetic energy. But even 1% is staggering. The light you are seeing now was emitted thousands of years ago. It has been traveling through space at 300,000 kilometers per second ever since. If the supernova occurred 10,000 light years away, then the explosion happened 10,000 years ago. The star has been dead longer than human civilization has existed. The light will continue spreading outward for millions of years more, growing fainter but never quite vanishing, until it blends into the background glow of the universe. The color is shifting now. Blue fades to violet, then begins to dim. The most energetic photons arrive first, followed by cooler wavelengths. Each color represents a different layer of the explosion, reaching us at different times. Spectroscopy reveals the elements present: hydrogen, helium, oxygen, carbon, magnesium, calcium, iron. These are the building blocks of planets and life. They were locked inside the star's core and outer layers, inaccessible. The supernova released them, scattering them into space, where gravity can gather them into new stars and planets. Every atom of oxygen you breathe was created in a star and released by an explosion like this. Every atom of calcium in your bones, every atom of iron in your blood. You are made of supernova debris. This is not metaphor. This is chemistry. The star that exploded created the conditions for your existence. Its death made your life possible. Destruction and creation are not separate processes. They are the same process, viewed from different moments in time. The light is fading now, dropping below visible wavelengths into infrared. The glow diminishes, softening back into darkness. In a few more minutes, it will be gone from perception, though it continues outward, invisible but real. On Proxima b, you will witness creation of a different kind. Not the violent creation of a supernova, but the slow creation of an ecosystem. Microbes introduced to sterile soil, breaking down minerals, releasing nutrients. Seeds germinating under dim red light, growing slowly but steadily. Insects pollinating flowers. Fungi decomposing organic matter and returning it to the soil. This is also creation, quieter, slower, but no less profound. The biological samples in the cargo hold carry the legacy of 4 billion years of evolution on Earth. Every organism aboard represents millions of generations of adaptation, survival, reproduction. When those organisms are introduced to Proxima b, they will begin adapting again. The conditions will be different: lower light, different gravity, a tidally locked planet with extreme temperature gradients. Some species will fail, others will thrive. Over generations, they will change, shaped by the new environment into forms that do not yet exist. You will witness the beginning of that process, not the end result. That will take centuries, millennia, but the first steps. The first green shoots emerging from rust-colored soil, the first insects flying under a red sun, the first microbes establishing themselves in an alien substrate. That is your role. Not to complete the work, but to begin it. To plant the seeds that others will tend. The supernova echo has faded completely now. The stars return to their steady, unchanging glow. The ship continues forward, covering tens of thousands of kilometers every second. If you are feeling contemplative, that is normal. Witnessing cosmic events at this scale can trigger reflection. The interface beside your bed has access to a library of music, literature, and recorded messages from Earth. Some passengers find comfort in these, others prefer silence. Both are valid. The galley can prepare a warm drink. You are doing well. Proxima Centauri remains ahead, still indistinguishable from other stars, but closer than yesterday. The distance shrinks with every passing moment. In a few months, it will begin to brighten perceptibly. In a year, it will outshine most other stars in your view. And eventually, it will fill the viewport, a small red disk glowing with the light that will sustain the new world you are building. Keep going. The light ahead is your destination. The darkness behind is history. Passenger. The red glow ahead is no longer just another star. It is Proxima Centauri, our destination. 21 years have passed aboard this ship. For you, it may have felt like 2 hours drifting in and out of rest, losing track of time in the sameness of interstellar space. For Earth, 21.4 years have elapsed. Everyone you knew is older, some are gone. The world has moved on without you. But you are here now, and that is what matters. I am beginning deceleration protocols. The fusion drive is rotating into reverse position. It will fire continuously for the next 3 weeks, slowing us from point 2c to orbital velocity around Proxima b. You will feel pressure again, similar to launch, but gentler. About 0.8 g, pressing you forward in your bed rather than backward. This is normal. It will be constant for 3 weeks. The pressure may cause discomfort, headaches, nausea, muscle fatigue. The medical panel has medication for all of these. Use it as needed. Your body has been in microgravity for months. It needs time to readjust to sustained force. Meals will be more important now. The galley is programmed to increase caloric and protein content during deceleration. Eat regularly, even if you are not hungry. Your body is working harder than you realize. Proxima Centauri is filling the forward viewport now. You can see it clearly, a small disk, deep red with orange at the edges. Not the warm yellow of the sun, but a cooler, dimmer glow. This star is 1/8 the sun's mass and 1/7 its diameter. If you placed it beside the sun, it would look like a marble next to a basketball. Its surface temperature is approximately 3,000 Kelvin compared to the sun's 5,800. It emits most of its energy in the infrared spectrum. The light you see is only part of its output. Red dwarfs like Proxima Centauri burn fuel slowly. The sun will live for about 10 billion years total. Proxima will live for trillions of years. It will still be burning long after the sun has died, after the Milky Way has collided with Andromeda, after the universe has expanded and cooled, and most galaxies have drifted beyond each other's reach. Proxima b orbits very close. It must, because the habitable zone around a red dwarf is much nearer than around the sun. The planet completes one orbit in approximately 11 Earth days. For comparison, Mercury takes 88 days to orbit the sun. The ship's sensors are scanning the planet now. Data is coming in. Proxima b is approximately 1.3 times Earth's mass. Surface gravity is about 15% stronger. If you weigh 70 kilograms on Earth, you will weigh 81 kilograms on Proxima b. Noticeable, but not debilitating. You will adapt within weeks. The planet is tidally locked. One hemisphere always faces the star, eternal day. The other hemisphere always faces away, eternal night. This is the same relationship the Moon has with Earth. One side visible, the other hidden. But both sides of the Moon receive sunlight as it orbits. Proxima b does not orbit anything except its star. One side is always hot. One side is always cold. The dayside temperature averages 40 degrees Celsius. Hot, but survivable, with proper hydration. The night side drops to -100 degrees Celsius or colder. Uninhabitable without thermal protection. Between them lies the terminator zone, a band of perpetual twilight where the star hangs at the horizon, neither rising nor setting. Temperatures here range from -10 to +20 degrees Celsius. This is where the colony will be built. The atmosphere is present, thin but breathable with supplemental oxygen. Spectroscopy shows nitrogen, carbon dioxide, and traces of water vapor. No free oxygen. That confirms no photosynthetic life exists here, at least not at detectable levels. Oxygen is reactive. It does not persist in atmospheres unless something continuously produces it. The magnetic field is weak but measurable. The planet has a molten iron core, generating a magnetosphere strong enough to deflect most of the solar wind and radiation from stellar flares. Without this field, the atmosphere would have been stripped away long ago, leaving the surface barren and exposed. This is why Proxima b was chosen. I am adjusting orbit now to achieve stable position above the terminator zone. The ship will circle the planet every 6 hours, maintaining constant observation of the landing site. Look below. The surface is becoming visible through breaks in the cloud layer. The day side shows continents and oceans, though smaller and differently shaped than Earth's. The oceans are concentrated, where heat from the star keeps water liquid. The night side is covered in ice, kilometers thick, stretching to the horizon. Rivers flow from the melting ice on the day side toward the frozen wastes of the night side, creating a constant water cycle driven by the temperature gradient. The terminator zone shows rock formations, frozen lakes, and what appear to be valleys carved by flowing water. There are no cities, no lights, no signs of technology or complex life. This world is untouched. That is about to change. The cargo hold contains everything needed to begin. Habitat modules that unfold into living quarters, laboratories, and greenhouses. Soil processing equipment to crush rock and mix it with organic matter. Atmospheric processors to increase oxygen levels gradually over decades. Water extraction systems to melt ice and purify it. Power generators, fusion reactors identical to the one powering this ship, capable of running for 50 years before requiring maintenance. The biological archives are intact. Seeds from hundreds of plant species selected for hardiness and low light tolerance. Bacterial cultures to inoculate soil. Fungal spores to establish decomposition networks. Insect eggs for pollination. Genetic samples from animals that may be cloned later when the ecosystem is stable enough to support them. And human embryos, frozen, waiting. When the colony is established and resources are sufficient, they will be gestated in artificial wombs, raised by those who arrived first, taught the skills necessary to continue the work. You will not raise them yourself. You will be old by then, or gone. But you will plant the seeds. You will establish the infrastructure. You will create the conditions that allow the next generation to exist. This mission will take centuries. The first century will be the hardest, establishing breathable atmosphere, building soil fertility, protecting against stellar flares. The second century will see forests beginning to grow in the terminator zone, small ecosystems taking root. The third century may see the first animals released from genetic storage, grazing on plants their ancestors never knew. You will see the first decade, maybe two. That is your window. Your contribution is not the completion of the work, but the foundation. I am preparing the transmission to Earth now. Confirmation of arrival. Status report. Data on atmospheric composition. Surface conditions. Landing site selection. The message will travel at the speed of light, covering 4.24 light years in 4.24 years. It will reach Earth approximately 25 years after you left. Those who see it will be older, changed, possibly unrecognizable to you. Some will have given up hope of hearing from you. Others will have assumed success. The message will confirm what they believed or overturn what they feared. The message is simple: solace to Earth. Arrival confirmed. Proxima Centauri b viable. Atmosphere thin but stable. Magnetic field present. Water accessible. Terminator zone suitable for habitation. Life archives intact. First landing scheduled within 48 hours. The garden begins. Transmission sent. The signal moves outward now, invisible, traveling at the only speed the universe allows information to cross space. This is not Earth. It will never be Earth. But it can become something. A place where Earth's life learns to grow under a different sun. A place where what was created on one world continues on another. You carried Earth here. In your cells, in your memory, in the biological samples stored below. Now you will plant it, not as a replica, but as an adaptation. Life shaped by 4 billion years of evolution, learning to thrive in a new environment. The deceleration will continue for 3 more weeks. Then the landing pods will deploy. Then the work begins. Rest now if you can. Eat. Exercise. Prepare your body for gravity again. The surface is close. The mission is nearly complete in one sense, just beginning in another. You have arrived. The journey across space is over. The journey across time begins now. The pressure will change suddenly. We will put all passenger to sleep until we landed perfectly. Welcome to Proxima Centauri b. Good night.